afternoon or good evening, wherever you are based. So, thank you for joining the session. And here, I'm going to introduce the robotics engineering program of Queen Mary University of London. So, I'm Dr. Ketou Zhang, and currently a senior lecturer in robotics. And I'm a member of the Center for Advanced Robotics at Queen Mary. And so here, let's move into the next page. All right, so first of all, I would like to give a brief introduction of Queen Mary. So we are a large university with over 25,000 students, including about like 18,000 undergraduates in the entire university. And the university has three faculties. Each of them has a number of schools, and the School of Engineering and Material Science is under the umbrella of the Faculty of Science and Engineering, and Robotics Engineering is one of the 8 undergraduate programs within School of Engineering and Material Science, but the teaching is supported by both the School of Engineering and Material Science and the School of Electronic Engineering and Computer Science. So here I would like to also give you some statistic numbers of students and also staff in the School of Engineering and Material Science. As for the academic year of 2022 and 2023, we have like about 1,500 undergraduate students in total, and including comparing, to support this large number of students, we have a good number of academic staff and also professional staff. That is total number of 209. And so among these staff members, we have 103 academics who are delivering the teaching and all the academic support to our students. And so if you're looking at the national numbers, and we have some statistical numbers. For example, the UK. So the average portion for the females in engineering is like 16.5%. But at Queen Mary, our undergraduate students, the rate of the female is about 26%, which is much higher. This shows the diversity of Queen Mary and also the diversity of the in the School of Engineering and Material Science. And before we talking about robotics, modern robotics at Queen Mary, I would like to share a video which shows some segments about the robotics at Queen Mary in the 1960s and also 1970s. I'm not sure whether you can hear the sound, but this video is basically to show you a robot, which is like a housekeeping robotic assistant, which was kind of like proposed, or a concept was proposed in 1960s, which is named Able Mabel. And this robot was kind of like proposed to be able to serve people coffee, and also can also doing this kind of like home assistance works. And you can see this robot can, for example, to vacuum the floor, but again, that's it's using a traditional vacuum machine. But nowadays, you may already have a vacuumer, robotic vacuumer is purely designed for vacuum the floors in your home. But what I would like to particularly introduce is this part. Jump a little bit. Is try to introduce our professor, Professor Song, who was working in the engineering building where actually our current robotics activities are based. So here the professor was showing the half-scale model of a robotic assistant, which has robotic grippers, and also, as what he was saying, the robot should have a computer, which from my point of view was already very advanced in the conceptual or in the development, because at that time computer is not that as that's good as what we have today. So here he's showing the another very kind of like prototype of the stair climbing robot, which was supposed designed to help people to, for example, carry someone which is unable to moving or climb the stairs. So that's the history about robotics at Queen Mary. So now let's move to the modern robotics. But the key message that we take away from that video is that a robot should has a computer, and also it has action mechanisms. So let's move to the next page. So that's actually from that key taking away message that we can find out why we at Queen Mary have the robotics engineering is supported by 2 schools under the umbrella of the Faculty of Science and Engineering. These 2 schools are SAMS and the school and the X, because SAMS is focusing more with on the action mechanism, which have all the kind of like expertise or components related to like allow you to understand what are the action mechanism of robots, all that knowledge related to that aspect. And from X, we have our colleagues specialized in computer science and electronics. They will teach you how or help you to understand about more computer science related aspects for robotics discipline. Of course, we also have associate members from medicine, biology. All these people are come together to support the multidisciplinary research, all this kind of like discipline or a field, the robotics field. So as what I mentioned, robotics is a multidisciplinary field. So that's why we have members are specialized in a diverse range of areas, including, for example, mechatronics, control, vision, and electronics, and also expertise in control, biomechanics design. And as I also mentioned, we have people in biology, behavior, and biomechanics. All these coming up together to fulfill the requirements to deliver the multidisciplinary subject robotics. Okay, so coming to the modern robotics at Queen Mary, I would like to first introduce a little bit about the Center for Advanced Robotics, what we are doing here now. We're doing more like human-robot interaction. For example, we design robots that can working together with our human or working with even children to clean up the rooms or kindergartens, for example. And we have assistive devices developed for rehabilitation and for processes. And we also have autonomous, for example, drones that can be used for delivery or other inspection tasks. related to electronics, we also have this researchers working on tactile sensing and also use the different type of robotic system for medical devices and also assistive devices. And we also working towards cognitive systems and the AI and the machine learning. So about one question you may ask is about why should you learn engineering, why you comes to robotics engineering. There are several main reasons. First of all, engineers are in demand. And the second is that engineers are paid higher salary compared to other graduates. The average salaries earned by the graduates, fresh graduates. Okay, and again, so especially for the robotics engineering, because you will cultivate your skills in like project planning, through the problem solving and creativity activities in the different modules, and your communication skills and other specialized expertise in robotics related subjects. So you will have higher employable opportunities during your career when you finish your robotics engineering program. And so here are some numbers that I extract from the website published by the Engineering UK. This was published in May 2023. And we have about 6.1 million people are working in the engineering area and also the technology related positions. So this is about 19%, or that roughly is 20% of the whole UK workforces. So then you can see how many positions are provided for engineers. And about this, they have like 25% of all the jobs posted in the UK are in the engineering and the technology. And so that means we have a huge number of requirements for the engineers. And so you may ask what exactly robotics are doing. So what is the robotics? So robotics is a sub discipline of the engineering. And so here, and it's also a multidisciplinary subject, because now we are the robotics is expanded not only engineering subject, but also it covers computer science. And so here we have some examples. For example, at early stage, the robots are used for entertainment. For example, this is kind of like humanoid robots and as kicking balls. This is called soccer robot. And we also have medical robots. And one of the robots here I would like to show is that the latest development of the most agile humanoid robots, which was developed by the US company called Boston Dynamics. So in particular, you can see this is like about 80-kilogram robots, which can jump and can also can turn its body and also flips. So this is a very agile motion. So also shows how advanced the control and the design and the power of a very complex system that can mimicking some of the human actions. And so for the robots, but nowadays most of you may imagine or you can see is in the factories, like for example, particularly in the car or automobile factories, the robots are used. An army of the robots are used to build the cars that now running on our streets. So robots are doing the welding, or robots are doing assembly of the bolts or car seats and any other electronics. They are all done by robots automatically. So in this case, all the robots are complete those labor-intensive jobs, but they free up the labors to human workers hours to allow them to do more skilled works. For the future, you will see more autonomous driving cars. You may already see some on the streets. And also you may live in a smart home with a number of autonomous or robotics technology-based equipments. When you finish your robotics program, so you will have a bright future professions. So what you can do is because you learned the skills to build robots and you learn the knowledge to how to use robots, and so then you will be able to select different careers for them to be as an engineer with a background in mechanicals or manufacturing technologies, or you can be also be an electronics engineer with your knowledge learned in electronics engineering field. And you will also touch the computer science, which is one of the most popular topic we are talking about. For example, you are talking about AI and the machine learning. That all comes from your modules related to the computer science. And so why I will persuade you to select the robotics engineer at Queen Mary, or what are the exciting points of this robotics program here. So first of all, it's a complete UG undergraduate program in this subject in any of the Russell Group universities at UK. So that is the first ever undergraduate program in robotics engineering. We offer that, and we have invested like over 5 million pounds to improve the facilities and to get everything prepared, or to prepare the facilities for the teaching activities for our undergraduate students. And also in the recent research, as I mentioned, Queen Mary is one of the Russell Group university which has heavily played in this, we have a lot of contribution in the research area. And so in the recent research evaluation framework, which was carried out in 2021, we are ranked joined 7th in the UK for engineering. That means we are in the top 10 of the UK universities delivering engineering subjects. And we have collaborations with different industries, so which will provide opportunities for our students for the industrial placements. And we run a lot of student lead learning activities at different levels from year 1 to finish your program. And so all these opportunities are going to prepare you to be specialized in, for example, medical robots, or you are able to handling the tasks in industries with working on areas related to the industry robotics, and all some of unsolved problems in soft robotics and the cognitive robotics. So overall, the robotics program at the Queen Mary is actually delivering by, as I mentioned at the beginning, is going to be delivered by 2 schools, including SAMS and IX, and you will learn the knowledge related to computer science, for example, programming, electronics, and you will also have the opportunity to learn the knowledge in engineering design, in experiments, and also attend in the societies for example, the student F1, which is supported by every year by SAMS. And about the facilities, come to the facilities where we invest a huge amount of money. One of the facility is the undergraduate teaching area, which has adjustable tables, and where we have monitors assembled, and so the computer also prepared the students can sitting together to solve their group, to discuss problems in groups and working on their coursework, for example, and the other student projects. And we have the advanced robotics lab, where we have students, PhD students working on their research project, and our undergraduates can also join them working on the final year projects. We have this drone flying test lab, and we have this maker space where students, after the training by technicians, they can use the tools and materials to carry out their own projects. And we also have access for the undergraduate students in robotics. They also have access to electronics lab, which is based in the School of Electronics and Computer Science. And for the advanced equipments, state-of-art equipment, we have, for example, robotic hands, and we also have the 3D printers and all assistive devices, for example, the mobile robots, and we have the drones and robot arms, where our students can work on their project in the final year. And so here we have some videos, some image showing that our undergraduates, they are working on the group project, and they're doing like the Viva of their M-Eng project report. So in this undergraduate program, robotics engineering, we also offer the opportunities for students to go abroad for 1 year. So this opportunity to allow you many different kinds of people and make a success of managing life and study abroad, and they enjoy your independence compared to studying in the UK. And this can also allow you to broaden your intellectual horizon. So you will experience different environments and learn more about other cultures, and then you in a different environment. For example, if you go to the US, you may learn some modules that are not provided in primary or in a UK degree. So it can also increase the chance to when you are in the job fighting stage. So the international experience actually enable you to stand out in a crowd, employee market, because with students with international experience can demonstrate they are willing to learn, or they are able to learn in a different environment, and they have different skills acquired from the year abroad study. Many of our students find that they also develop a network of valuable international contacts. So this can also provide you opportunity to learn another language that maybe you can use that for your entire life. So that's all the advantages for you to taking a year abroad. And so we also, in parallel to the a year abroad study, we also offer the opportunities for our students to have the option to take a year in industry, which is called industry placement. So so this is what I want to mention is that you can either do a year in industry, or you can go a year like for abroad study, but you can only select one of that. For the industry's placement, it normally take place after year 2 or after year 3 in both B-Eng and M-Eng programs. So for the benefits when you take in a year in industry, so you will gain valuable work experience in a real industry environment. So you can strengthen your CV and increase employability. So you can also develop key skills in communication, problem solving, and team working. So this industry placement also counts towards the requirements of applying to be a chartered engineer, and also makes professional contacts, allow you to make professional contacts in the relevant industry. So as what we mentioned before, you can expand your network. Also, this allows you to discover more about a potential career for yourself. Of course, during this placement, you will be able to earn a salary rather than spend money in the school. So that's other advantages of a year in industry. And so come to the details about the robotics engineering program. So here, by years, this is a key example structure for the 3-year program, B-Eng program. So we offer the core robotics modules, including exploring robotics, and also in the second year we offer the 2 essential key robotics module, including the robotics and the mechatronics and aspects of robotics. In the third year, you will do the core module, which is the modeling and control of robotic system and advanced robotics in your second semester of year 3. In parallel to these core modules, you will also have the essential modules, component modules, which include math, where you will learn is combined with mechanics and also design, engineer design. And in the first year, on the other side, provided by X, are the programming electronics. In the second year, you will have the chance to learn the microcontrollers, signal systems. And in the third year, we also offer you the artificial intelligence module on artificial intelligence and the embedded systems. And on the right-hand side, on the right-hand side of the column, which are the unique modules in the SEMs we provided to our undergraduate students, because these modules are purely provided for robotics students. So other students in other programs in SEM school, they don't have the chance to access these modules. And for a typical week, so because every term or semester, you are going to take 4 modules. So each module have 3 to 4 hours of teaching hours. So that means you have about up to 16 or about 15 hours of lectures. And also you will have 4 hours problem solving solving classes among these 15 hours. And so then you will have about 14 hours available for lab work and for revisions. And normally we put Wednesday afternoon free for other activities, including sports or other social network activities. And for each module, there are several different types of assessments, including, for example, learning engagements. That's for the entire, this will be checked along the teaching for the entire term. And there will be coursework reports or mid-term exams or final exams. And this depends on the setting of the modules, but most of the modules have only 2 elements, so you need to complete. This page gives you an example of the module. Sorry, I'm not sure if this screen is still sharing. Okay,
we can still see your shared screen. It's on module example.
Okay, cool. Thank you. Yeah. For the module example here, this is the second year module called Design and Mechatronics. So here, in the video that you show that in this module, our students going to design from scratch a robotic system, which has a mechanical system. They will using different materials, for example, wooden bars and the 3D printed parts, and then making an assembly. And then they will select the different type of motors and to do the wiring, and then they will develop their control system to implement this type of writing motion. So this is, as what I said, this module is delivered in the second year of your study, and then students will learn how to design, manufacture, and program a complete robotic system. And here they work in small groups. And so this gives you the knowledge, like kind of summary about what type of knowledge you will capture during this the whole program. This will span from design of electronics or mechanical system, and also about how you develop a system, and also on the because robots is a complex system. This will allow you to see how you solve complex problems. For example, to compose a complex robotic system. And then you will learn the knowledge related to the computer and embedded system, and also how to program the programming languages. And you will have the little touch on the artificial intelligence in the final year, and also about economics and human factors. And through all the years, you will gradually manage the develop knowledge regarding to the management and architecture of technical systems. And come back to the skills. So what kind of like skills you will develop? You will develop skills in making controllers and making electronics or electronic components, and you will have the huge amount develop huge opportunities, a lot of opportunities to developing your programming skills. Use different languages, for example, Java, C, and Python, and you will be able to use softwares to do mechanical drawing, and also doing manufacturing. For example, use 3D printer, and you will also have the develop skills in, for example, for inter-human machine interface, and so all these kind of like a diverse range of skills that will be unique for to be captured by our robotics students. And in the final year, normally you will do a final year project. So from this year, all the students will do a group project, but they need to finish their own individual tasks. For example, the previous years, our students do soft robots. They developed this type of robotic devices made out of soft materials. And so, for example, after assemble 2 segments of the soft elements, so the robot can implement certain tasks or dexterous manipulation. And we also have our students develop this type of variable soft grippers with variable stiffness fingers. So this can be used to grasp objects with different shapes or different but made out of the different materials. Here is you can adapt to the cylinder, and as you can see in the previous grasping test, it can grasp like adapt to a rectangular or cubic shape. And so regarding some of the work done related to the electronics, so here students use tactile sensor which is mounted on the dexter robotic hand, can be used to assist the robots to implement grasping and dexter manipulation, like what our human hand is doing. And also prosthetics. So here is a complete soft robotic hand made out of a silicon material. There's no electronics in this robotic hand, so it's purely powered by compressed air. For example, you can a syringe to generate the pressurized air, and when you inflate, So you can see the fingers will bend, and this is robotic hand is as the size of a 5-year-old child. And so here you can see the actions, texture actions of the robotic hand, and also our customized engineered soft squid. And here has another project also involve our undergraduate students. We have these drones can act autonomous tracking the trajectories. This was the experiments done in the drone flying space, which is called Q Arena. Okay, so here is a summary about like you learn different code modules, you learn through the final year projects. So, and I also mentioned about your career. So then you mean as what I mentioned, you can be a operation engineer, it can be a design engineering or system engineering, or even you do the computing IT like IoT software engineering. And so all this type of job you can, because of your skills, you can adapt to the requirements for this type diverse range of the jobs in the as an engineer. And we have get some rough numbers of salaries for our graduates who finish the robotics program, and which are good numbers. It looks so for the destination. So where are you going to find a job? So based on our data, so our students, for example, the software engineer, they working in the IT companies, and some of them after finish the program, they find a consultancy job. These are some of the example of representative companies, and also there are number of students went to further study into academia, for example, doing MSc program, further MSc program, either at Queen Mary or in other universities in the UK, or even do a PhD project in Queen Mary or other universities. And some of the major players who are working on advanced robotics, including, for example, Dyson, Amazon, and Google. We also have Ocado, who has close collaboration with us. And there are other companies making industrial robots, for example, KUKA, the ABB, all these major companies or players in robotics. You may find a job after your graduation in the robotics engineering program. And the final bit is about the support that we give to you. So after you enroll to the program, from your first week, come to Queen Mary. So we will have the welcome week, and we will have the week of the introduction activities to let you know how your life on the campus, university campus will be looking like. And in the modules, then you will learn the different type of skills. And we also offer personal tutorials, either individual or groups. So then you can contact your advisor. And we also have this special scheme which called PASS, where the older students actually support you when you first get into the university and along the learning journey. And we have a teaching assistant, which are graduates who will provide high-level support during your study. And we also have this career support, include career workshops, where they will help you specialized experts who will provide you opportunity to look at your CV to further develop your CV, for example, working on the cover letter, writing of the cover letters, and also provide you the interview tips before your while you are finding a job. They also give the chance to do the mock interview to improve the successful rate. And we have the industry placement manager, as what I said. You have the chance to go to an industry for 1 year. So we have a special person there, the industry placement manager, who will help you to liaise with the company for the placement. And then after you go in there, they will be the key contact point. Then to make sure that the reports, everything, assessment is done in the right time, and to make sure that you have a happy life at the placement, during the placement. And we also offering this industry lead forum. Every year we have 2 forums to allow you have the opportunities to have direct contact with our industry collaborators. And also you have the opportunities to visit industrial partners, either in small groups or large groups. So this normally happens in both year 1 and year 2. Finally, the requirements. So for the A level, it's basically we are mainly looking at the A levels results. This including for the B entry is the AAB, and the mandatory one is the math, and the other 2 you can select the other 2, including second math and or physics, electronics, or chemistry, or computing. But if you want to apply for the MEng program, then you need a 3A. That's it. So, and lastly, this is our beautiful campus, located near Mile End Tube Station, or Stephen Green, and we are one of the largest campus, university campus in London. All right, thank you very much. If you have any questions, please do type in the Q&A section. Myself and Michael will be able to answer. Okay, so here we have one question which is not answered. So how is the course split? How much engineering do we learn about in portion to the amount of AI we learn? Okay, so the AI, well, so what I can tell you is about the modules that be delivered by the EECS, which is the other school, electronics and computer science school. So every year you will have about 2 modules from that school, and so this including programming and also the electronics, and so this kind of like it's you can calculate or estimate how much is from the modules are delivered from different schools, basically these 2 schools. And for the AI bit, so the AI, because the programming, the AI is related to like the you learn on the model, and modeling, how you model, and then how you program develop the AI model. So I would say this is AI is a mixed topic, mixed subject, and so you can't really see what is the portion between the engineer and the AI, but most of the modules are more on the engineer, including mechanical and mechatronics engineering. The AI will be built on your first year and second year study on mathematics and programming, and in the third year you will be able to touch a little bit on the AI. I hope that answered your question. Another question for taking a MEng. So MEng, so that allows you to have another year to do the modules. For example, you have learn more AI or machine learning related topics, and you have a core module, which is you will working in group on the research. We call it like research projects. So research group project. So this allows you to develop skills in like planning your task and working in groups for the communications, and then to management of delivering a complete system by the end of the project. And also this is like a same level as MSCs in the same subject. So that is what I can provide you at the moment about the benefits for the MEng. And anything to be added by Michael on the MEng program, the advantage of the MEng?
No, I think you covered that, Keitao.
Okay.
Yeah, I think it's as an option. You know, you can choose to apply for the MEng at this stage. It does have a slightly higher entry criteria, although you can also apply to extend your program onto the MEng at a later date. So if you are unsure if the MEng would be appropriate or right for you, you can make that decision once you join the university.
Thank you, Michael, for adding that.